When defining induction, it is helpful to reference two laws that govern its characteristics. According to Lenz's law, a change in magnetic flux through a loop causes an induced current. So here we have a uniform magnetic field in a loop going into the board. Increasing this magnetic flux into the board causes an induced current. This current is directed so that it creates an induced magnetic field that opposes the change in magnetic flux. So we want to create a magnetic field coming out of the board since we have increased into the board. So this current goes counterclockwise. Here we see there's a current induced only when there is a changing magnetic flux through the coil, and not when it briefly remains at rest. With Faraday's law, we realize that in general, current is a consequence of EMF, or a voltage buildup. So our induced current must be caused by an induced EMF, given by this equation, change in flux over change in time. So a changing magnetic flux causes a voltage buildup, and therefore an induced current. So, in South Korea, the principle of electromagnetic induction has been applied to electric vehicles and roadways to create a system that charges your vehicle on the go. So the idea is to create a road with a conducting coil in it through which alternating current will pass. The current passing through the coil creates a magnetic field, which in turn creates a corresponding magnetic field in a second coil, which is located on the floor of the car. These changing magnetic fields create a current in the second coil in the car, which is then used to power the car. This setup is based on the idea of a transformer. Here, current from one coil of N1 turns induces a magnetic field, which induces a current in the second coil of N2 turns. Induced voltage depends on the ratio of the number of turns of each coil. So this is just crazy. We can create a road that uses electromagnetic induction to power and charge our cars. Environmentally friendly solution, I would say.